Okay, now let's continue our discussion of the formation of clouds and how clouds function in weather and climate. Yes, I want you to draw this diagram on the left in your notes right now because we're going to use it to explain some basic concepts about cloud formation. So take a second, draw this diagram, and then we're going to talk about it. Again, you don't have to be an artist, but clearly the person that drew this wasn't an artist. I couldn't do it as well, but anyway, label it correctly, and then we're going to explain it. Okay, write in your notes that in the morning, this field is relatively cool. Question, why is that? If you said because the land loses heat at night, you'd be correct. We discussed that when we talked about land and sea breezes. Now, let's write the steps in this convection process in your notes. So you're going to write them as steps underneath this diagram. Okay, step 1. The sun heats up the field because land absorbs the sun's radiation. We've talked about that a lot. Remember that the atmosphere gets heated because the land absorbs the radiation from the sun and then reflects it back out as heat, and that heats up the troposphere. All right, step 2. Now, certain areas of the field begin to heat up more quickly than others due to the different terrain or surrounding conditions. For example, bare soil heats up more quickly than soil with vegetation. Question, why is that? Well, remember that plants absorb radiation to photosynthesize, okay? Whereas land absorbs it and then re-radiates it as heat. Not that plants don't give off some heat, they do, but not nearly the magnitude of the heat that's given off by the ground. So bare ground absorbs more heat than anything with vegetation or trees or whatever on it. Step 3. A thermal, also known as an updraft, make sure you get that in your notes, can form. Now, what we mean by a thermal is a rising blob of warm air due to the unequal heating of the Earth's surface. So, let's go back to our vegetation. So if we had a field full of vegetation sitting next to a bare field, the bare field would be certainly re-radiating a larger, warmer blob of heat than the one with vegetation on it. We call that a thermal. So make sure you get that example in your notes. Okay, step 4. Since the thermal forms at the Earth's surface, it's warmer than the surrounding air. And warm air has a tendency to do what? If you're shaking your head going rise, that's correct. While cool air has the tendency to sink. That's correct. So when you have these two blobs of air, think about the field with the vegetation and the bare field. That bare field air is rising much faster than the vegetation field because it's warmer. Remember, it's called a thermal. Thermal means heat. Step 5. Now, as the warm air rises, it will begin to expand and cool. And it'll continue to do that until its temperature is the same as the surrounding area or temperature. The process of thermals forming in the atmosphere is a form of convection. Think about it. You have these blobs of hot air rising and this cooler air falling. So that creates a cycle just like it does in the rock cycle. All right, just exactly like it does. It's the same kind of convection for the same reason, only now we're talking about air and not molten rock. So you got to make that connection. I'm going to ask you about it, I promise. on a quiz, and you'll get asked about it on testing as well. So make sure you see the connection between this kind of convection and the kind of convection that moves the plates in the rock cycle. Okay, so in a nutshell then, convection is basically the transfer of heat, in this case through thermals, from one area to another. Now in our example, the heat was transferred from the surface into the atmosphere. And although we can't see thermals with our eyes, we certainly can feel and observe their results. For example, many birds will use thermals to fly higher in the air. By catching a thermal, remember, thermal is a rising blob of hot air. By catching a thermal, birds don't have to expend as much energy to gain altitude, since the rising air will carry them which way? Upwards. And that's why you see the birds and planes right here. They all take advantage of these rising thermals. Now, the reason I have this picture in here is that hang gliders also take advantage of the thermals to gain altitude and fly while gliding in the air. Really seasoned hang gliders can feel these rising thermals, all right, and will stay on those rising thermals to gain altitude. Now they also, use the wings and the aerodynamics of the hang glider, but they're looking for thermals to keep them up in the air. So, how does convection actually help in the formation of clouds? Well, as we mentioned earlier, when a thermal rises, it begins to cool and expand. Now, question, why is that? Remember, the molecules in a thermal are moving much faster because it's hotter. When they move faster, they bump into each other a lot more and therefore create space between each other. As they create space, we're talking about expanding. Now, so when a thermal rises, it begins to cool and expand. But why does it cool and expand as it rises? Let's try and understand this process. Now, if you've traveled, especially into higher altitudes, maybe you've tried boiling water in higher altitudes, or maybe even on a mountain if you're like a backpacker or a camper or whatever. Write in your notes that water boils faster on a mountain than it does at sea level. So it boils faster on a mountain than it does in sea level. Let's explain that. Now, because the air pressure is lighter on a mountain because it's further from sea level, it's lighter on a mountain than at sea level, so water actually starts to boil below 212 degrees Fahrenheit. Also write that air pressure decreases with height. So there's less pressure on this thermal, and because the thermal is warm, it wants to expand. Also write that by expanding, the thermal will also begin to cool, and as it cools and expands, it reaches a point where condensation starts to occur. So let's think about the water cycle, okay? We talk about condensation all the time. So condensation literally is where water molecules are squeezed together. That's why they're condensed. So that's why it's called condensation. You see it right here. See the word condensation. So what I want you to think about is the air around this glass, this warm, moist air. Now, warm, moist air is relative. It's warm and moist relative to the outside of the glass. Now, this glass is cool because there's ice in it. All right, so we're going to compare the warm, moist air. So here's this air mass that's warmer and has lots of little water droplets in it, hitting now this cool surface. Same thing happens when you take a shower in your bathroom and the mirror fogs up. Fog is nothing more than water droplets. So let's try and explain what we mean in terms of clouds. So, write in your notes that when water condenses, it goes from a gas to a liquid. Now to visualize this, think of a glass of ice cold water like we see here sitting outside on a hot summer day. Now you may have noticed that tiny drops of water collect on the side of the glass, just like you do on a cold mirror in the shower. This cold glass of water is actually cooling the air right nearby it. And by cooling it, it causes the water vapor that's in the air to condense, right? When things get colder, the molecules move closer together. We talked about it in terms of cold air masses and warm air masses in terms of fronts. That warm air mass has lots of room in it. That's why warm air masses typically have water in them. Cold air masses do not. That's why when it's really cold in the winter, like it has been lately, below zero, rarely is it snowing because the air has no water in it. Now, when we talk about lake effect snow, when that cold air moves over the water, which is warmer and has more water, now that air fills up with water and it can condense into snow. But in this situation, this warm, moist air hits this cold glass, and the air right around that glass cools and condenses and squeezes the moisture out of this warm air. And that moisture then forms on the side of the glass. We call that condensation. Now, so what, right? Well, this is exactly what happens to that warm thermal, that moist thermal air as it rises. So as it rises and cools, all right, that air is squeezed together and the water begins to squeeze out of it. Okay, as it squeezes out of it, we now have the makings now of a cloud. So you need to be able to explain this condensation process as it applies to the glass, and then here in a minute as it applies to cloud formation. It's the same thing. This warm, moist air would be a thermal, and as it rises into the cooler atmosphere, all right, it now squeezes this warm, moist air, and that water begins to condense. And as it condenses, now the drops get bigger and bigger, and a cloud forms. Okay, write in your notes that while the droplets that form on the outside of the glass are relatively big, what we mean is relatively big compared to the droplets that are contained in the air that you're sitting in right now, that has water droplets in it. The droplets that form in clouds are extremely tiny and are light enough to float in the air. And also write that once the air reaches saturation, which means it can't hold any more water, once it reaches saturation, which is the point at which water vapor condenses, clouds can begin to form. Now sometimes thermals don't become fully saturated and never produce clouds. So the only time clouds are produced is when there's enough water to saturate the air. Once that air is saturated, which means it can't hold any more water, think of a sponge. All right, you dip a sponge in water and it can only hold so much, and when you pull the sponge out, the water it can't hold drips out of the sponge. That's exactly what happens when a cloud forms. In this case, dry convection would be taking place where there's not enough water to saturate it. Warmer air at the surface is being transported into the cooler air in the atmosphere, but no clouds form. So the idea here is clouds only form when the air is saturated. When it's not, they don't form. So think of that. Air's got to be fully saturated, full of water before clouds form. That's why, think about it, that's why clouds are an indicator that precipitation might happen soon. So make sure you get that in your notes. Okay, that's a lot. So that's it for part 4 of this podcast. Take a picture of your notes, submit those notes to Moodle, grab that part 4 study guide and answer the questions, and I'll see you soon in part 5. Bye.